Alright, this video is going to cover area of different shapes, including triangles, trapezoids, kites, circles, regular polygons, and parallelograms. Okay, now here we're looking for the area of this shaded or this darker orange trim, I guess. They tell you that this represents a wall around the black rhino enclosure at the zoo. The dashed line is the inner fence. The zoo personnel are only ones allowed in this walk space between the wall and the inner fence. The inner space for the rhinos, represented by the dashed lines, so this yellowish area, is 320 by 186, and they have that labeled with these arrows. Okay, so rectangle, they've told you it's a rectangle, so that's base times height. Okay, the fence is 15 feet away from the wall, so this distance right here between the two is 15 feet. All the way around, it's 15 feet. Okay, top, bottom, left, and right. This distance is 15. So we're going to find the inner rhino space first by doing 320 by 186. And that gives you 59,520. Okay, so that's inside. Now we have to figure out the outer wall area, and then we can subtract to get the difference. Remember, difference means to subtract. So to get the total length, we have 320 from here to here. We have to add in 15 on each side. So 320 and 30 is 350. So my base is 350. Okay, and then they'll have the 186, and we have to add 15 to each side, so that's a total of 30, which gives us 216. So 216 times 350 is 75,600. Okay, and that's the entire rectangle. They just want the difference, so then you subtract. So we're going to come over here and subtract 59,520. Which gives you 16,080. So the walk area is 16,080, and this was measured in feet, so this is area square feet. Alright, here now you have a square with an area of 196 meters squared. Remember, this is base times height. Or for a square, you can think of it as side squared. That's the same thing. In this case, side square is just going to be a little easier for us. So area is 196. They're asking us for the length of the side, the S. So to get rid of that squared on the S, you do the opposite, which is square root. And that gives you a total side length of 14, and that is all four sides. If this was meters squared, the length is just meters. Now for perimeter, you would just take 14 multiplied by 4, because that's how many sides there are, so there's 56 meters in the perimeter. Here we have another right triangle. They didn't have it marked, but they did say here that it was right. Okay, it tells us area, which is 1/2 base times height, is 49. One leg is 7. So one of these two legs, remember this is hypotenuse. These are the legs. One of these legs is 7. We don't know which one, it doesn't matter which you label. Okay, so we can call that the base or the height, but the legs in a right triangle are the base and the height, because that's where the 90-degree angle is made. So if I plug in a 7 here, I can work backwards to solve for h. Half of 7 is 3.5, and then I need to get rid of it by dividing. It was being multiplied by h, so the opposite is to divide. So 49 divided by 3.5 is 14. So the missing leg is 14 meters. Okay, now we're getting on to our circles. We have a circle with arc AB shown to have an arc measure of 80 degrees. That's your A. Remember, that's congruent to your central angle. It asks us to find the arc length if the radius is 4. So if my R is 4, how do I find the arc length? Remember, arc length is going to be a portion of the circumference. Circumference is 2 pi r, but we don't need the entire circumference. We need a portion of the full 360. Our portion is 80. Okay, so we take 80 over 360 and multiply that by 2. And our radius, we can plug in a 4. Now, if you're asked to leave your answer in terms of pi, then you would just write your answer pi. Okay, so let me show you how to do this in the calculator. So 80 over 360 times 2 times the radius. Okay, I wouldn't want it as a fraction if you're leaving it, I would want it as a fraction, not a decimal, if you're leaving it in terms of pi. So 16 over 9 pi. Okay, and this was in meters. Okay, and this is just a distance, so it's just meters, not meters squared. Now, if you're asked to give this as a decimal, you can round and show you how to do that in the calculator. You can say 16/9 and then go ahead and multiply by pi. Here's pi, so I hit second and then this button to get pi. So 16/9 pi as a decimal is approximately 5.59 if we're rounding to hundredths. Still in meters. The area of this sector, here's the sector they're talking about, is going to be the same process. It's still just 80 degrees out of 360, but instead of circumference, it's area, which is pi r squared. And we know our r is 4. So we're going to have 80 over 360 times 4 squared. So 80 over 360 times 4 squared. Okay, again, hit math, enter to get it as a fraction. 32/9. And if we want it as a decimal, we'll go ahead and multiply that by pi. And it would round to 11.17. So 32 over 9 pi, or 11.17. Also in meters. Okay, so these are two correct answers, just a different form. Alright, last but not least here on our review of area is combining different area formulas. In the center, they tell you that this is a square with side measures of 6. Okay, so we have 6 by 6, so the area of the square is 36. Okay, this outer circle here, we are going to need to know the radius, which is from the center out to the edge. Okay, we don't have that given to us, but we can use this right isosceles triangle that we created by cutting the square in half to get that length. Okay, the diagonal of the square, if you look at this as half the square, we have 6 by 6, and we want to find this piece. You can do Pythagorean theorem, you can do special right triangles, or you can do trig, because we know that these are 45-degree angles because it was a square. Okay, so if you remember, the quickest is if you remember your special right triangles, this would be 6 square root of 2. Okay, because remember those are the formulas for special right triangles. Okay, and that's all the way across. Now we only want half of that for our radius. So we would take 6 square root of 2 over 2. 6 over 2 is 3. So we'd have 3 square root of 2 as the radius of that inner circle. So to get the area of this inner circle, pi radius squared. Okay, you can do this in your calculator, or if you want to do it by hand, just be careful that this squared goes to the 3 and the square root of 2. When that happens, 3 squared is 9, and square root of 2 squared just cancels the square root and the square, so you just have 2. So you end up with 18 pi, and that's the area of the smallest circle. Okay, we're going to do the same formula for the larger circle, but notice this distance between the small to the outside of this middle one is another 6 centimeters. So instead of just 3 square root of 2, it's 3 square root of 2 plus another 6. 3 square root of 2 plus 6 squared. Now this, rather than doing this, because this is going to confuse a lot of y'all, I would go ahead and have you get a decimal. So 3 square root of 2, close the parenthesis, plus 6 is approximately 10.24. So here I would have you put 10.24. So 10.24 squared is going to give you 104.86, and we still have pi. Okay, and that's the medium circle. Okay, and the larger circle, the outermost, adds another 10 to that. So it was 10.24. Add another 10, it's 20.24. So we have pi 20.24 squared. 20.24 squared is 409.66, and we still have pi. And that's the area of the largest circle. So what they're asking for is the combined shaded area, so these two orange sections. Well, this outer one is going to be the largest square minus this middle square. I'm sorry, I'm saying square. The largest circle minus the medium circle. So my largest circle was 409.66 pi. My medium circle was 104.86 pi. These both do have pi in them, so I can just subtract the coefficients. So 409.66 minus 104.86 is 304.8. Don't forget the pi. Okay, so that's this orange annulus. Okay, so we're not quite done yet. Now we need to find these little orange pieces. So this is the inner small circle, and we take away the square. So the inner small circle was 18 pi, and we need to take away the square, which was just 36. So 18 pi minus 36. Now you can't just do 18 minus 36 because this one doesn't have a pi. So we're actually going to have to calculate in that pi. So to show you that, you would do 18 pi minus 36. And that's approximately 20.55. Okay, so now that's the inner shaded section, and this is the outer annulus. So now we have to combine those. So we have our 20.55, and we're going to add 304.8 pi. So plus 304.8 pi. A grand total of 978.11. Okay, pi is no longer in there. We typed it in the calculator. This is all centimeters squared. That one was pretty complicated. Hope you followed it.